Welcome to the Unconference session on the future of technology. I am Nirav Mehta from San Jose, California. I run a software services company where we work with technology businesses, helping them develop the right technologies for their requirements. I will be moderating this session. We have a wonderful list of sessions today with topics ranging from software engineering and AI to 5G and patents. Our first speaker is Mr. Rajendra Singh. He is a senior digital development specialist with World Bank. He has 40 years of experience in telecom sector. He will be speaking on next generation spectrum management. Mr. Rajendra, over to you.
Thank you, Nirav. I'm just sharing my screen. Okay, thank you very much. Thank you for giving me this opportunity, and this is a wonderful and amazing event. Very interesting sessions. The one thing which is coming to all of us are thinking about it. That when we are talking about AI and ML and various activities, the basic foundation which is required is high-speed internet connectivity. And to do this kind of infrastructure, one thing which is completely under the control of the government, or you can say where the government has the monopoly, is the spectrum management. And on one hand, we are seeing like a tremendous growth in terms of like different network technologies and various applications. But my presentation, what I'm going to focus is that the governments also have to move for next generation of spectrum management and how it is going to change. So basically, I'm going to cover my presentation in 4 parts. Like we have been hearing about, like spectrum is a scarce resource, and so what I'll be talking is it really scarce, or we are using it inefficiently, or it is kind of a source of earning the revenue to the governments. Then I'll talk about what is the network economics and the infrastructure sharing, then briefly about physics of spectrum management, and then what is the way forward. Now, those of us who have been associated with the telecom sector, if you look at the worldwide mobile, basically they have been using mainly 3 spectrum frequency bands, 900 megahertz, 1800 megahertz, and 2.1 gigahertz. So you can say that most of its spectrum was kind of sub 2 gigahertz worldwide. Now, what has happened now? We have moved to, there are spectrum which is being allocated now. It is starting from 600 megahertz and you are going into millimeter wave, you can go up to even 100 gigahertz. Higher spectral efficiency. If you look at like the spectral efficiency factor, which is in 5G services, it could be in the range of about 5 to 6 and sometimes even 7 to 8 times what was in 4G. We are using beamforming technology, and why this is important from the spectrum management point of view, that you can have a very focused transmission and reception, and you can have network slicing. We are having like separation of indoor and outdoor, and what it means is, most of us, when we are using our mobile phones, about 70 to 80% of the time we are within the buildings. So the network design, when we are using our phones within the building, has to be different than outside the buildings. And that's why the spectrum management has to be done accordingly. Dynamic spectrum sharing, and in optical fiber technology, already like per wavelength, we are having 800 Gbps. That kind of growth in optical fiber, virtualization, softwareization, telecom cloud. So, and tremendous growth on data services. Now, when you look at all these things, the question really comes that because of all these technological developments which are taking place, because of the millimeter wave and so much frequency available, do we really feel that spectrum is still a scarce resource? Is there any question of like demand and supply situation. And that's why, we have to follow the conventional method. And my answer is no, we have to change this. Another interesting thing, if those of you who are following like the 5G development and the kind of networks which are happening 5G, what is remaining with mobile operator in terms of the infrastructure is mainly radio unit, antenna, and the connecting cable. Like backhaul or front haul or whatever, like towers, power supply, distribution unit, central unit, they are moving to the cloud and infrastructure is being outsourced. Already the radioactive network, radio access network are being shared. And not only like in the developed part of the world, but in developing world, like from the World Bank side, I was leading a project in Tanzania, where one component of the project was that we had about $30 million funding for increasing mobile connectivity in rural and remote areas. And there, the mobile operators, they were already sharing the radio access network. So what I'm talking is not something like, which is futuristic and this thing, this is already happening. Now, the point is that the kind of innovations and what we have been hearing like yesterday and today, the whole this thing is that the telecom infrastructure will be taken like, okay, this is there, but the more and more innovation will take place in service. And this will become like a service and not like infrastructure. And therefore, the mobile operators in future, they are going to move from providing the infrastructure, rather they will focus more on providing the services. We worked with government of Mexico from the World Bank side and a concept of wholesale LTE network. Mexico government and regulator, they decided that instead of duplicating the infrastructure, there is a wholesale LTE network operator countrywide, and even a small, like there is an entrepreneur who wants to offer different kind of services in a cluster of villages where, conventional mobile operators may find it a bit challenging, they can do so. So it all depends upon what kind of requirement are there in the sector. And therefore, this kind of competition, like the conventional infrastructure-based, may not work in future. Now, those of us who studied, telecom engineering during our IIT days or wherever you have studied, we must have a very simple equation, this Shannon's law, like 1948, when he was working with Bell Labs, like the channel capacity is equal to bandwidth multiplied by this logarithmic function. Now, what this graph is basically indicating, that if you look at it, if you plot this signal to noise ratio, a limit comes when this logarithmic function becomes flat. And therefore, if you want to increase the channel capacity, the only way you can achieve it by increasing the bandwidth. And the amount of data traffic, which I mentioned in the previous slide, like in about by 2026, this Ericsson mobility report, the latest report, they pointed out that 54% of the mobile traffic, data traffic, will be on 5G, and it is going to be like 5 times than what it is today. So you can imagine the kind of growth which is taking place. And therefore, the only option which will be left will be that we have to increase the channel capacity. We have to increase the bandwidth to increase the channel capacity. Now, what it means is, and if you look at it, the kind of applications which will be there, ultimately bandwidth is going to be the differentiator. And therefore, we are not going to work in that kind of approach that, okay, like 10 by 10 megahertz allocated to 4 operators, did the auction, and then we got billions of dollars out of it. No, that approach may not work because we have to avoid the fragmentation of the spectrum. we have to allocate the spectrum in the range of like 400, 500 megahertz, because then only we are going to achieve kind of giga bandwidth uplink and downlink, which is required depending upon our growth of data services. The point which I want to make through this presentation, that what's the way forward? And my suggestion to all spectrum managers, and that from the World Bank side, also we are trying to suggest this approach, that let it not be treated like what is the source of revenue to the government. During last 2 days, we have seen what kind of innovations are possible. You know, our youngsters, startups, to do all these things, whether you are working in education sector, health sector, fintech, or any other area, what is basic requirement is that high-speed internet connectivity should be good quality and affordable to our masses, especially in developing world. And therefore, my suggestion is that let spectrum be managed like sea and not like land. What I mean by this is, no one is owning Atlantic Ocean or Pacific Ocean. You know, the ships from different countries, from different shipping companies, they are crossing these things. And it's not like that, you know, there are certain rules which are to be followed, and every shipping company has to follow that. Same approach we have to follow in spectrum management. Government should lay down that, okay, these are the rules and regulations which you have to follow, and then leave it to the industry. How do they manage, instead of doing the fragmentation of the spectrum, and instead of sitting over it and then killing the innovation in kind of network technologies, which can evolve if we follow like more innovative approach in spectrum management. With this, I will stop my presentation, and thank you very much for giving me this opportunity, and I'll be happy to take if there are any questions. Thank you, and over to you, Neerav.
Thank you, Mr. Rajendra, for a wonderful session on spectrum management. And to the audience here, if you have any question for Mr. Rajendra, please ask in the chat box provided by IIT2020. As of now, I don't see any questions. And if I don't see any question in the next 10-15 seconds or so, I will move on to the next speaker. Okay, let me move on to the next one. So our next speaker is Dr. Shiva Kintali. He is the founder and CEO of TrueDat. Before founding the company, he taught in the CS department at the Princeton University. He will be talking on preventing and detecting fake photos and videos using AI and blockchain. Dr. Shiva, over to you.
Okay, thank you, everybody. So I'll be talking about preventing and detecting fake photos and fake videos using two of the technologies that are recently on the rise. One is artificial intelligence, other one is blockchain. So if you have noticed, there are three trends that are going on recently. So one of them is that people are increasingly consuming news from social media, like WhatsApp, Facebook, and Twitter. And Facebook and Twitter, for example, they have recommendation algorithms, and they are creating these information bubbles and creating increased polarization. And it's also getting very easy to create and share fake photos and fake videos on these platforms, which are spreading 6x faster than the real news. So it's very disturbing trend which led us to a post-truth dystopia. For example, here are some examples of photos. As I said, it's getting very easier to edit photos, manipulate the metadata, and even generate fully artificial deepfakes. And fakes are being used to create socioeconomic and political chaos in several countries across the world. So let's take some examples and really define what's meant by a fake photo. So here is an example of it. It's a clear example of a fake photo. On the left side, you see a real photo of Obama. And on the right side, it's a manipulated photo of Obama. Okay, so that's very clear. Clearly, it falls in the definition of a fake photo. And this was shared on Twitter in October, leading to our November election in US. And there are several videos where people made some very simple changes. For example, there was a video of Nancy Pelosi last year where the video was slowed down. When you make the video slow down, when you slow down the video, it appears that Nancy Pelosi was drunk. So that was widely shared on Facebook. And there were several videos of Joe Biden leading to the election in November that were falsely edited. And these are very simple edits. They're often called cheap fakes or deep fake or dumb fakes. So that's one definition of fake photos. And sometimes people also mistakenly share some photos. For example, ABC News shared this photo of this bombing footage on their TV channel. And they said that this is what's happening in Syria. But the actual footage turned out to be, it is from some place in Kentucky. It was a military show. So that was by mistake. And again, Los Angeles Times shared this photo of a beach saying that this is a beach in Los Angeles, but it's actually a photo from Florida. So these two are examples of mistakes. And here is on the left side, there is a photo of Joe Biden on a plane. And this was circulated on social media just one day before the election with a false claim saying that he did not wear mask on his plane during his campaigns. But this photo is actually from last year, November 2019. So that's again an example of a fake photo. It's a real photo taken in November 2019, but it's shared with a false claim in November 2020. So that's again definition of a false or fake photo. Same thing with the photo on the right. And here are a couple of examples from India. There was a photo of Prime Minister Modi, which is essentially fake, which was shared on WhatsApp and Facebook, and it created a lot of chaos. And last but not the least, the metadata of these photos and videos is also very important. The type of lens you are using, the type of camera you are using is very, very important. Here is a very interesting example where the photographer took a photo of a crowd on a beach. And he took this photo with a lens of, let me see, something like 330 mm lens. So it really makes a difference which kind of lens you are using. If you know photography, the type of lens you are using makes the crowd appear large or small. So that's a small puzzle for you. So find out what kind of lens will make the crowd dense or less dense. So it's very interesting. So people assume that there is more crowd, but actually aerial photos showed that they are actually maintaining social distance, most of them. So the metadata is very important. That's the point I'm trying to make here. And as I mentioned, it's also becoming very, very easy to create completely artificial photos and videos. On the left, you can see several completely artificial photos. On the right, there is a technology where if you just give one photo, you can make a completely artificial video out of that photo. And you can make that person say anything in that video. So the technology has advanced a lot. So what's our solution? So at TrueDat, we built a solution. So I'll focus on one part of the solution for now, which is an iOS app. So we developed an iOS app, which is very similar to an Instagram app, if you look at the interface, but it has an inbuilt blockchain. So when you take a photo with our app, there are several security checks that happen inside the app. I'll go through the list in a moment. But essentially, it's a digitally signed and verifiable and tamper-evident photo, and that you can share with anybody on WhatsApp, on Facebook, anywhere. So when you share the link, with one click, you can verify the authenticity, both the authenticity of the photo and also authenticity of the metadata. And we created a community and a marketplace within the app to make sure that people who are creating these real videos have some incentive to sell them to media companies or any magazines all over the world. And not only you can create the photo, you can track the provenance of the photo entirely. For example, I gave you an example of people making mistakes, sharing the photo with wrong location. So since we are tracking the entire provenance of the metadata, such mistakes can be avoided. So let's talk about the security checks that we have. So when you take the photo using our app, there are several security checks that happen on the device. For example, if you have jailbroken the device, we detect that. And if you have made any kind of modifications locally, we detect that. And there are several mining algorithms that run on the device to make sure that you're not making any changes even to the metadata. And the latest phones these days have LiDAR sensors and use those LiDAR sensors to detect whether you are in a 3D environment or you are in a 2D environment. So we want to distinguish that, because if someone takes a photo of a photo, we want to make sure that that's considered a fake photo. So those are different security checks that we have. We also have API security, making sure that our blockchain APIs are actually called from the app and not from a script by some hacker. So I won't go through the details of blockchain, but there are several problems with the existing blockchains. For example, the transaction fees are very volatile. The mining can be very ASIC friendly. If it is ASIC friendly, then it can lead to centralization. So we designed a new blockchain which has ASIC resistant mining and zero transaction fees, and we implemented true digital ownership into our blockchain, and we made it scalable because we are focusing on this particular use case of tracking the provenance of digital data. We made it much more scalable for this use case. So there are three layers to the technology, where we have the underlying technology. Underlying layer is the blockchain, and on top of that, we created an API. So very interesting aspect of this API is this API can be used to make any data tamper-proof. For example, if you have credentials, let's say I'm from IIT Kharagpur and I went to Georgia Tech and I taught at Princeton University, all these credentials can be issued by those respective universities using our platforms, and they are digitally signed, and you can prevent the credential fraud also using our platform. So that is our long-term goal. Our long-term goal is to make sure that any kind of data can be made into tamper-proof data to prevent fraud in several areas. So that's one part of the story, where we have this kind of a truth machine, where anything that's originating within this truth machine is true with a very, very high probability. You can share that on social media along with a proof, along with a mathematical proof that it hasn't been tampered since its creation. On the other side, people share all these fakes online. So we also created this detection platform. This is where the AI comes in. So as I mentioned, deepfakes are becoming more and more popular. In fact, the same technology that's used in generation of deepfakes can be used in detection of fakes too. Here are some examples. Without going to the technical details, one can check that face boundaries are blurred. Most of the fake videos have blurred boundaries on the face. The skin tone is different sometimes. There are flickering lines, blurs, inconsistent skin tone. These are, some of them sound very simple rules, but they become very useful when you're applying them on really important videos, like political videos or mostly political videos. Sometimes they have cropped effects, and in fact, I said mostly political videos, but we also have done demos in online adult websites where people create some porn videos of some actresses or some people and upload them on adult websites. That's where we saw very high success rate. So as I said, we have to detect these cropped effects and boxes, and we want to detect the inconsistent video quality. So for example, if you notice the photo that I have shown, the Obama photo, the fake photo is of low quality because it's very difficult to make a high quality fake photo. Let me go back because that's very, very important. Let's just compare that for a moment. If you see these photos, the photo on the left side is very, very high quality. The photo on the right side is very low quality because they want to hide all the noise and make it appear like a real photo. So the detection of the quality is also very important, inconsistent qualities in the photo. So this is what I call full stack photojournalism. On one side, we have this tamper-proof provenance. On the other side, we have fake detection algorithm. The first one uses mostly AI. The first one uses blockchain. Second one uses artificial intelligence and GANs. So I want to leave some time for questions because this is a very important topic. So this is my contact information. If you want to contact me, we are working with many partners, media companies and politicians and celebrities and adult websites and so on. So if you want to partner with us, if you want to know more details, send me an email or follow me on these social networks. And that's our link, truedat.co. So if you have any questions, I'm glad to answer them now.
Shiva, we actually have one question. It's from Karthik Chandra. He's your batchmate and hostel mate from IIT Kharagpur. He currently works as a guest anchor for a Telugu news channel. And he has asked if you can share your thoughts on how TrueDat could be applied in Indian mainstream TV media.
A very important question. Very interesting question, because if I list the number of fake news that I'm seeing and order them, US and India are number one. And I'm really surprised about the number of fake news that are coming from India. And I'm part of several WhatsApp group. I think Karthik is probably part of the same WhatsApp group, which I'm also using in IIT Kharagpur classmates. And we notice several fakes, and they come and we discuss, people discuss, and I come back 2 days later and say that, hey, this is actually fake. And people are surprised that's actually fake. So it is a very high impact area, India, where we are working with a couple of media companies in India. Please contact me offline too. So the way we work with them is we give them this entire provenance tool. So they have journalists on field, and they also use citizen journalists. So because we have our app and also our API can be integrated into many of the professional cameras, our API and the platform can be readily used by these media companies to make sure that the real photos are being transferred in a tamper-proof manner from the point of capture to the till it's broadcast on TV or online. So please talk to me, Karthik. It's a very high impact area, and I'm glad to help you. So that's how we are helping them. We are helping them in getting the entire provenance in a tamper-proof manner. And also connecting them with the citizen photojournalists and tapping into that extra footage that they're getting from millions of citizen journalists in India.
Shiva, so there is one more question from an anonymous user. Are news media corporations installing such software for all the journalists to check before publishing?
That's a good question. So for example, some companies already have full-time journalists. So when you're a full-time journalist, there is some kind of trust already built between you and the photojournalist. So you don't need an external tool there. But often these mistakes happen. For example, the ABC News mistake and the Los Angeles Times mistake, they're very costly mistakes. ABC News was very criticized, and they quickly become very political, and people started attacking ABC News from everywhere, right? So you want to also avoid such kind of PR nightmares. So that's why these kind of provenance tools are very useful. Even if you have trusted journalists, you want to make sure that you're not making any mistakes. And also you can tap into the citizen photojournalists, as I mentioned. And to answer your question in one sentence, yes, we are working with more than 50 media companies in US, and they're very, very excited. In fact, before talking to us, they didn't know that there is a solution that exists for this problem. So the short answer is yes. And again, if you want more details, please contact me by email.
Shiva, thank you for a great session on how AI and blockchain can help identify fake content. This is definitely the need for the day, and I hope the technology gains traction so that humanity is better educated about the veracity of this news.
Thank you, Nirav. Thank you for organizing everything.
Thank you. Our next speaker is Dr. Santi Advani. He works at Rocket ML, and he will be presenting on efficient deep learning for computer vision on HPC servers. Dr. Santi, over to you.
Thank you, Nirav. So AI is everywhere, including our speaker before, Shiva mentioned how AI is being used to detect fakes. It's with us starting from the time we wake up all the way to sleep, to helping us with navigating, helping us with email spams. It's helping us a lot. So in my talk today, I'm going to give a quick primer on AI and tell the challenges of AI and what is the next frontier. So the two terms, right, AI and machine learning, are generally used interchangeably, and I'll be using the term machine learning in most of my talk today. So for those of you who are coming into this area at a very high level, the machine learning or AI is actually two separate steps. There is one step where you're actually training a machine to learn, which is an offline process. And there is another step where the intelligence is actually consumed. So there is a product, there is AI produced and there is AI consumed. So most of the work goes in actually creating these models that can be used in the final product. So everything that we use on our phones is an online process where we are actually consuming AI. And everything that happens on the cloud is generally offline, and that's where AI is actually created. So today I'm going to dig a little deeper into the process of creating AI. What are the different ways of doing it, and what are the current challenges, and what can we do next? So machine learning is basically a lot of iterations. You start with some data, you iterate, create a model, you see whether it is working or not in the real world. You go back and you take more data and you iterate and iterate and iterate. So while iterating, you eventually find one model that could potentially work well, and that's what you deploy, and that's what we use on our phones or cars or everywhere. So within this process of creating the model, there are two main methods that people use. One is called a fully supervised learning method. The other one is a fully unsupervised learning method. So the difference is this. So machines don't know anything by default. We have to teach them, right? So what that means is you need to show machines a lot of data. And when we talk about data, it's not just showing an image. You need to also say that an image maps to something. That is, if you show it a dog image, you have to say there's a dog. If you show a cat image, you have to say it's a cat. So by giving millions of the samples, right? Millions of samples and millions of labels is when the machine can say, okay, I understand what you're talking about, and this is the model, and that is actually deployed and we use it. This is the most popular way of actually doing machine learning today, right? That is fully supervised learning. That is, there's a lot of samples, a lot of labels, and eventually you get a model that is deployed and you get to see what's happening. So deep learning is one of the techniques to do that, but this method is expensive, right? If you have to create millions of labels to come up with a model, then it takes a lot of time, effort, to actually create these labels and say something works, right? And a lot of cases, this is not robust. That is, if you perturb your input a little bit, the machine learning model cannot actually say something is good or bad. So on the right-hand side, what I have here is they perturbed the stop sign a little bit. That is, they added some patches. And the machine learning model found that it's not a stop sign, but it's a speed limit sign. So what would happen if an autonomous car actually sees that and drives through? So there are a lot of problems with these supervised learning methods and deep learning methods where the amount of labels and the data may not be sufficient to create a robust model. The other side is unsupervised. That is, you do not give any labels. That is, for any given image or text, you don't say what the corresponding label is. You let the machine learn something. You say, give me some clusters, give me some anomalies. And the human intuition has to come in to make sense of what comes out of it. So these are at a very high level, two extreme ends of machine learning that are happening today. But if you notice, most of the learning is used in areas that are known for majority of people, right? That is in data where everybody can label. But what about the areas where labeling is hard and expensive? For example, if you take on the left-hand side some use case in biology, you want to identify boundaries on a cell, or if you want to identify where pancreatic cancer area is in an MRI image, or when you're working with manufacturing images, finding defects. Labeling these kind of data requires a lot of domain expertise, and it is very expensive and hard. So the next generation of AI is basically trying to solve these hard problems where labeling is very hard. And that's where there is a whole gray area in between supervised learning, where you have a lot of need for a lot of labels, and fully unsupervised learning, where you do not need any labels. So this middle space is where the future lies. And I'm going to talk about one specific problem here, which is self-supervised learning. So self-supervised learning is where you take the best of both worlds. That is, you start with a lot of samples, that is a lot of data without any labels. And you make the machine learn just from that. That is, you take the data and you say, perturbate a little bit and try to predict what's going to happen. And you use samples without any labels and make the machine learn about the features in it. That is, you give images and say, find where the edges are. You give images and say, find where the corners are. And it basically extracts all those features. And then you give small few labels, right? You don't actually say, I need millions of labels. Maybe 100,000 labels would actually be sufficient for it to do a good job at predicting what's going to happen. So self-supervised learning is actionable with less labels. And this is also shown to be robust to any perturbations, and also interpretable. That is, you can actually interpret what's going to, why a model behaves certain way by using these techniques. But the catch is how accurate it is, right? So it's been shown, these are very recent results. This is 2020, where self-supervised learning results have actually surpassed supervised learning. That is, they are actually doing much better than what a supervised learning method can do. The problem is with this requires a lot of infrastructure. You need hundreds of CPUs, hundreds of GPUs to churn through a lot of unlabeled data, because once you say you don't need labels, you have a lot of data to work with, and it requires a lot of in-house expertise. So we provide, we have a solution for that, which is based on high performance computing for large scale machine learning, which brings together cloud, high performance computing, and machine learning together to address this specific problem of large data sets and self-supervised learning. If you want to learn more, I'm not going to talk in details about it, but we have a booth, just ping me and we can chat more about the solution. But I'll give you an example. So there's a classification problem from electron microscopy, right? That is, you have a lot of SEM images, scanning electron microscopy images, where you want to detect whether there is a defect or not a defect. And by running through these self-supervised learning techniques, what we have found is you get as much accuracy as if you use 10% of the labels, and not 100% of the labels, you actually get very similar accuracies. So it can be shown that if you don't have labels, that is okay. You just have to use a different kind of techniques and different types of methods to solve some of these tough AI problems where getting labels is hard. So in conclusions, like learning is possible with very few labels, and self-supervised learning requires experimentation, and that there are scalable algorithms that are cost-effective that can be used to address these challenges. Thanks, Sunil. Thanks for organizing this. I'll take any questions.
Thanks, Andy. We actually have one question from an anonymous user. How does the human intuition feed in for unsupervised learning, and what is the mechanics?
Yeah. So when you're trying to take a lot of data and say you create a model and you see a bunch of clusters, right? So then as a domain expert, you need to come in and say if those things actually matter, or if those things actually make sense. If they don't, you need to go back and tune your model and build a set of new clusters. Right? So for example, say if you already know that your data is going to split into 5 different sections or 5 different clusters, that is the kind of intuition you want to tell the machine, and that is used to create certain information. Right? So that's where human intuition is needed to interpret the results coming out of unsupervised.
One more question. How do you, I guess, what do you do when self-supervised has reached an optimal model? Or how do you know when self-supervised has reached an optimal model?
So there is a step here where you actually use test data, which was not used for the training in before, right? And you normally have a test data which you would run with the built model and see how well the model is actually doing with the test data. So that's how you validate whether your model is working correctly or not.
Thank you. I'll wait for 10 or 15 seconds for any other new question. If not, we'll go to our next speaker. So Santi, thank you for presenting a great session on how to improve the efficiency of implementing unsupervised learning on HPC servers. Our next speaker is Ms. Mayuri Sengupta. She is actually joining from India, where it is 3 a.m. in the morning. So thank you to Mayuri. She is a manager at Intellectual Property and Technology Transfer Department in the Government of India. She is also a head research fellow of IIM Kashipur and alumnus of IIT Kharagpur. She will be speaking on the subject Friend or Foe, Patents for Technology Arena. Mayuri, over to you.
Thank you, Nirav, for the kind introduction. A very good afternoon to everyone in US and a good evening to those in India. I would like to thank the organizers for allowing this platform to share my topic of interest, Friend or Foe, Patents for Technology Area. So coming to intellectual property, there are 8 different forms of intellectual property where patents is what we will be talking in detail with. Patents are for inventions or technological innovations. Trademarks are for protecting brands or brand names, as you see the Apple emblem. Copyrights are for literary and artistic works, like the Gitanjali book that I have shared, which earned a Nobel Prize in 1914 for India. Designs are for aesthetical features. It does not relate to functionality. Geographical indications like Darjeeling tea or champagne are for appellations of origin, which are products which have certain characteristics which are attributed to the place where they originate from. Then we have protection for ICs, semiconductors and ICs. Trade secrets are for secret formulas or information which the owner or the company does not want to make public, and therefore they keep it as a secret, like the Coca-Cola concentrate, which has been a secret for more than 120 years now. Traditional knowledge is knowledge that has been passed on from generations, which is also a form of intellectual property, like the antiseptic properties of haldi. So we will come to patents, which is what our topic is about. Before that, why is intellectual property and innovation management important? Why do we do it at all for innovation-based and technology-intensive firms? Because it has, in a knowledge-based economy, protection and management of intellectual intangible assets has become a commercial imperative, which requires a set of best practices which would help us harness and exploit it to the maximum, or stand to lose out if we choose to ignore it. So the basic tenets of intellectual property management are identifying the information, evaluating it, identify the information, evaluating it, protecting the same, and using or exploiting it to the best possible manner. So coming to patentability criteria, patents are for any technological innovations which are inventions. Now, how do we distinguish between innovations and inventions? An invention would be novel, that is new, it has not been done before or been seen before. And invention can be a process, a product, or a product by process. Non-obvious means it would not be obvious to persons skilled in the art. Like you cannot basically tinker with 2 or 3 known technologies and create an invention. It doesn't work that way. And if a person skilled in the art can predict it, then every single document predicts it, then it can be anticipated. The third and the most important aspect of an invention is its industrial applicability. That is, it should be replicated, it should be capable of replication, and like being capable of being manufactured in industries. So for example, an abstract theory like the theory of relativity is not an invention, even though it is novel and non-obvious, because it does not have any industrial applicability. So again, why do we patents? The motives of patenting are many, as you can see on the screen. First is the traditional protective motives, and then there are the strategic motives. So the traditional protective motives is preventing imitation, like a patent grants you a conditional monopoly of 20 years. So it prevents your competitors or any unauthorized user from copying it or using it for business purposes. The second one would be the licensing revenue. You can license, sell, license it out to on a single, exclusive, or common basis and earn revenues out of it. Freedom to operate means since you have the patent, you can operate in that technology area and no one can preclude you from doing it. Blocking again is the opposite of freedom to operate. You prevent a potential competitor or a potential new entrant to the market by using your patent rights to exclude him from the arena. Then negotiation during collaborations and M&As is an important aspect of the motives why firms and people patent. Cross-licensing is a new thing that has come up more recently of late, because by cross-licensing, for example, you have a technology and your competitor has a technology, and you need to run a product or service which requires both the technologies to be used in simultaneous synergy. So for that, cross-licensing is used. It is more applicable for standard essential patents, which we have for our mobile phones, those kinds of technology. Now, another influence that motivates people to patent is the influence on standardization, because patents are novel, new technology. So whatever you patent, you create that new technology standard, which guides the rest of the world. For example, we have the Apple inventions from iPads to iPhone to everything, which are considered as the threshold level or the best that is there, or even the vaccines that we are that the whole world is awaiting. So that is the threshold or the maximum technology which helps, like which standardizes what the others or the rest of the people will do. Attracting funding is an important proposition, monetary wise, for patents, like it earns economic grants. And also, whether you are in university or whether you are a company, patents will help attract funding, and it has been proven that venture capitalists are more interested in funding technologies that are patented or pending patent applications than those they are not. Then assessing innovation performance, patents are also an indicator of innovation. So it is an it is a standardized gauge used to see how innovative your company, your technology, or your firm or your research is. And finally, enhancing reputation, because patents are an indicator of innovation, and it is a sort of informal certification that it is the best that is there and it has not been done before. So it enhances the reputation of the owner to a considerable extent. For example, the universities who have patents or the companies who have patents are ranked high in their respective indexes. So it affects everything from your credibility as a researcher if you're in academics, or your stock prices if you're a company, or your rankings if you're a university. That is why these are different motivations which enables one to patent. So is it a friend or a foe? It depends on how well you manage your patents. Because patenting again is a double-edged sword. While your patent can help you gain a monopoly, conditional monopoly for a limited amount of time and earn revenues, the same patent, if is owned by a competitor, can prevent you from actually entering the business, doing the business, or even like for forging into new technological arena. And if you want to use the competitor's patent, then you have to pay a hefty licensing fee. And sometimes when companies disagree on the intellectual property rights or the patenting aspects, they sue one another and go into lengthy litigation, which again drains out the R&D efforts and expenditure. So that is why it is very important to manage patents in a judicious manner so that it can be used as a best possible way and to prevent running wrong on running amok from a legal perspective. So the solution would be a holistic patent management process where you see the first is the research and development, then you assess the patentability, which is if it is positive, like depending on the earlier stated novelty, non-obviousness, and industrial applicability criteria. If it is positive, then you go file for a patent IP registration. If it is negative, then you have to work around and see whether your technology can be improved, or whether a competitor has a related technology which will prevent you from going into business or bringing out your product or services. So the difference for individual inventors, universities, and firms or entrepreneurs come from the commercialization aspect, which is different for everyone out there. So for each in the different types of IP owners, the patent management process after IP registration would be different, because some go directly into production, some give out for licensing, and others would try to like open a tech startup. So that is where strategic IP management comes into play, because without a correct strategy, patents would be poor, and you have to holistically and properly manage your patenting process right from inception to the end, so that it helps you in economically and otherwise also in the long run. So basically the patenting process or the inception should start quite early from R&D aspects, because one important aspect of patenting is that a patent is granted to the inventor who is first to file and not first to invent. And because it is a jurisdictional right, territorial right, so you have to file differently for different countries. Like for the same patent, you have to file once in India, once in US. So there are again processes like the Patent Cooperation Treaty to harmonize the same and given some leeway to the inventors. So that is there. And let's connect our intellectual property, patents, and technology transfer. You have my email ID. And if there are any questions.
Thank you, Mayuri. We actually have a question.
Mhm.
What are your views on India not recognizing some of the US or global patents? Does it help or hurt India?
Uh, this is, uh, it depends on which side of the grass you see it from. Firstly, as I said, patent is a territorial right. So the laws of different countries are different. US has a easier standard of patentability compared to India. However, after the passing of ratification of trade-related intellectual property rights or TRIPS by WTO, there is a minimum standard which every country should adhere to. And then there is a sui generis procedure where every country, according to their requirements, can like change it or tamper it a little bit. So, as far as India is concerned, India has some very positive laws regarding patent use or like the in especially in the pharmaceutical sector, it has been an effort of the Indian governments from a lot of from the past to not allow evergreening of pharmaceutical products, which means that a pharmaceutical product, maybe you tinker it a bit, like change, then again continue patenting it so that it is out of reach of common people. This is especially true for drugs. And currently, in this pandemic situation that we are in, it is more important than ever that health is accessible to all. An iPhone may be a luxury, but a vaccine is a necessity. So, that way, uh, patenting, if you see, patents are public documents so that the knowledge is shared. The inventor earns a 20-year monopoly over it in lieu of sharing the information. So the essence of patenting is sharing the information so that it comes for the use of other people and for the society as a whole. So we need to look at it from that aspect and take it with a grain of salt. To each their own.
Thank you. One more question for you. How strict is the patent enforcement in India these days?
Patent enforcement is strict, but you can say that the litigations are tedious and takes a long time to get resolved. But however, the granting of patents, that granting time has been reduced considerably ever since certain measures were taken and the process was taken online.
Thank you. I don't see any other question in the chat box right now. So we'll move on to the next session. So yeah, Mayuri, thank you for an interesting session on patents for technology.
Thank you.
And in fact, we the speakers had more questions for Dr. Santi as well as Rajendra, which I missed earlier because they came in late. So if we have more time after the next session by Dr. Shivanand, I'll open up the floor for some more Q&A and the speakers can respond then. So again, if you have missed asking a question before to any of the speakers, please write in the chat box right now. This is the time. Thank you. Thank you, Mayuri. So our next speaker is Dr. Shivanand Handigund. I hope I pronounced his last name correctly.
Yeah, Handigund.
Okay. He's also joining from India. It is 3:15 a.m. So thank you. He was a professor at engineering institutes in Karnataka and has 45 years of experience in technology and research. He will be speaking on the subject of resuscitation of software engineering to enhance the success rate of developing software. Basically, how to develop software better, faster, more efficient. Dr. Shivanand, over to you.
Thank you, sir. Thank you very much, sir. So, good wishes to all the delegates and attendees. And my topic is resuscitation of software engineering to enhance the success rate of developing the software. So let me start the discussion, bowing my head to the feet of my great Guruji, Professor D.B. Phatak of IIT Bombay. Right, sir? And normally the software engineering means people twist their nose. Anyway, I will deliver the lecture and then I will submit this screen to you because there is a short of time. So in the software engineering, people feel that it is a dry subject and they twist their nose. Because the software engineering considers the lot of heuristical guidelines and there is no concrete methodology to develop the software. Normally, as our Prime Minister yesterday told in one of the hymns or sagas that reform, transform and perform. That means reform is an ongoing process in all walks of life, and for the reform we need to transform, and for the transformation the performance is necessary. And here to develop the software we are using different models of the software development life cycles, like the waterfall model, incremental model, evolutionary model, spiral model, prototyping, formal model and agile models and all that. So in choosing these or in transforming the one model to another model, normally they don't make any root cause analysis, and they simply change the models, and simply changing the models will not help in developing the software. And our my suggestion is to enhance the success rate of the software. To enhance the success rate of the software, we need to inculcate the mathematical rigor and logical positivism. So the vision of the discussion is to disseminate the resuscitative techniques to be adopted in software engineering to enhance the success rate of developing software. And the motivation is to incorporate mathematical language concepts and logical positivism in the real sense of software development life cycle in software engineering arena. So the software development life cycle means nowadays the software is developed ignoring the software development and also the life cycle. Life cycle means there are number of stages. The stages may be the requirements gathering stage, the analyzing stage, designing stage, coding stage, testing stage, the implementing stage, deploying stage, and lastly the maintaining stage. So in transforming one stage to another stage, they have not made any MP-Spinian document at the end. Therefore, there is a necessary to inculcate mathematics, and I tried to inculcate mathematics, but because of the million word English language, the requirements gathered document cannot be transformed into the matrix form. So what is meant by software? Software is the transformed version of machine understandable transformed version of million word English language pragmatics into 300 to 500 word programming language pragmatics. And to urge the creation of the stage software documents, because life cycle means we need the MP-Spinian stage document, and to urge get that stage document we need to inculcate the mathematics. So at present the success rate of the software development that can be considerably improved through the inculcation of mathematical rigor and logical positivism in the tools and techniques of all stages of software development. The current software engineering is pedestaled on heuristic guidelines. The success rate of these guidelines depend on human skills and is to be made independent of it. Nowadays, there is a different bifurcation between the mathematical experts and also the computer science expert. Mathematics experts are laymen in engineering applications, and computer science scientists are laymen in mathematics, and there is an urgent need to bridge the gap for enhancing the success rate. In Indian scenario, with most populous country in the world, earning foreign currency through skilled work is quite essential, either being in India or at abroad. One has to earn the foreign exchange, and then only the country will prosper. So here I tried to redefine the engineering and also the software and software engineering, and then I will go to the at least the first 3-4 stages, how the mathematics can be inculcated and replace the guidelines into the mathematical techniques. So engineering means the utilization of scientific knowledge for optimal practical use in planning, designing, constructing and managing the tools and techniques or machines, etc. And software is the transformed version of transformed machine compatible and compact pragmatics of subset of million word English language pragmatics. And software engineering is the application of engineering knowledge in the above transformation process. And these definitional principles are to be incorporated in all the stages of the software development. Then only the software success rate of the software development that enhances. So as I already told the stages, and in the first stage, that is as I told that here in the software development, we are transforming subset of million word English language pragmatics into 300 to 500 word machine compatible pragmatics. And for that one, there are stages. And in all these stages, the richness of the language is to be well defined, and it has to be maintained. And the only except the requirements gathering stage, in all other stages I have made the mathematical tools for transforming the one stage document into another stage document. So in the however, I have developed some guidelines for the requirement stage. The guidelines are: convert multi-statement sentences into single statement sentences, replace pronouns respectively with their immediate, prior, subjective, possessive and objective attributes of the values, rewrite passive voice statements into active voice statements, resolve the synonyms and homonym issues, retain the declarative and imperative statement, because in an English language there are 4 types of statements: declarative, imperative, exclamatory and interrogative. So we don't need interrogative and imperative. So then we eliminate the go-to statements, and go-to statements can be eliminated through the mathematical tool, and then assign consecutive number to each statement of SRS, and then this will form n by 4 matrix form, and n means the number of statements. And in the analyzing stage, actually the analyzing stage means it is the structurizing the machine memory so that it can understand, or so that it facilitates the ALU to process the software. to process for the development of the software. So in the of course, one more thing, in the design stage, the project schedule network diagram is also there. Earlier it is called as an activity chart, and it is also to be automated, and I have automated it by taking the input in the matrix form and then processing it through the traversal of the matrix elements. And in the analyzing stage, right, the purpose of the analyzing stage is to, the purpose is to structure the computer memory so that it facilitates the arithmetic logical unit to process statement by statement in an optimal way. And for that one, we are using object-oriented paradigms. But in the object-oriented paradigms, there is an absence that the object-oriented paradigm developer, they have developed what are the components of the object-oriented, but they have not developed how to abstract these components from the requirement specifications. And we can obtain the requirement, the components of the object-oriented paradigm through the n/4 matrix, which is the reformed version of the gathered requirements. And here only, except of course in the components, means the components may be the object classes, attributes, actors, object methods, object states, visibility, interrelationships, association, aggregation, superclass, subclass, hierarchy, and all that. And these are, except the visibility, all other things are mathematically can be abstracted from the the matrix form of SRS. And I have already been tested it, and we can develop except the visibility. So visibility cannot be abstracted from the matrix form of SRS. But if we blend the database management system into the object-oriented paradigm to make it as the object-oriented database technology, and then we can transform of course we can implement the visibility in the form of schema and sub-schemata. And in between the analyzing and designing stage, so the MPSBinian document at the end of the analyzing stage is the schema and sub-schemata. Sub-schemata are given to each end user, and for the security purpose. That means sub-schemata are the subset of the schema assigned to each end user separately. And
Dr. Shivanand, your
yes,
time is up. Do we have?
Yeah. I will. 2 minutes, sir. 2 minutes. And right. And in the design also, the unified modeling language diagram is quite completely incomplete, and there is a need to assign specific meaning to each subset of the UML diagramming components. And here we are using the mathematics that one and simple one and onto mapping to transform the analyzing stage document schema and sub-schemata into different diagrams. And lastly, in the from mapping to design to staging code, intermediately we are using the algorithms, and algorithms are nothing but they are the programming language independent version of the transformation of the design diagrams. So the diagram, of course, the abstraction also can be made with the program slicing techniques and other things. And I have developed a formula to identify the richness of the language as in the numerator the syntactics minus the synonyms and heteronyms, then add pragmatics, and in the denominator semantics minus semantical synonyms and heteronyms, then add pragmatics. So the richness of the language is to be maintained. Right, sir. Okay.
Unfortunately, I'll have to stop you here because we are running out of time.
Okay, sir.
Thank you for your wonderful session. And again, if you want to share your LinkedIn profile or anything on the chat of IIT 2020, please do so that people can contact you if they have any questions for you.
Sure, sir.
And I just came to know that this unconference session was attended by about 200 people. So thanks a lot to the audience for showing such enthusiasm in attending this. And unfortunately, we don't have a lot of time as I foreseen earlier, but as of now, we have two outstanding questions, so I'll get them through. First question is for Mr. Rajendra. Given the pervasiveness of wireless devices, will we ever run out of spectrum? And again, you probably have like 15-20 seconds, so be as short as possible.
Thank you. My answer to this question is, as I said, that it's a question of how do we manage the spectrum. I don't think there will be shortage, and as devices will become more and more intelligent, I think devices themselves can manage the spectrum, and there will be no shortage of spectrum as such. Thank you for the question.
Thank you. The next question is for Dr. Santi. Can somebody who is not a guru in machine learning still use them? By them, I'm assuming unsupervised models meaningfully.
Absolutely, yes. You don't have to be an ML guru, but even if you know a little bit of ML, if you try to use some of the platform that I was talking about, the whole idea is to reduce the barrier of entry for a lot of ML folks who are not gurus to actually use them. So absolutely.
Thank you. This brings us to the end of our unconference session on the future of technology. I would like to thank all the speakers for educating us about where the technology is progressing. Above all, I would like to thank our audience in making this session a great success. Thank you.
Thank you. Thank you very much.
Thank you, sir. Thank you.